Hi, this is John Linneball of John Linneball Tutoring, and this is How to Study for the SAT and ACT Math Section Systems of Equations. If you like this video, please click the little thumbs up symbol beneath the video. Please subscribe to my channel, and please click the little notification bell symbol so that way you'll be notified when I release new videos. Alright, so systems of equations. What I mean is we're going to be dealing with linear equations where they describe lines. So if you graph them out, you can have intersecting lines where they have one solution. You can have two equations that are really the same equation. They give you the same line. Then there are infinitely many solutions because these lines go on forever. Or you have parallel lines that never cross, so there's no solution. So there are three ways to solve a system of equations: graphing here, substitution, where you solve for one variable, then you substitute that variable into another, or elimination, where you line these up and add downwards. So we'll go over that some more. What's a system of equations in the first place? Well, a system of equations is a problem where you have two or more equations with two or more variables. Equations like these are sometimes called simultaneous. So you must have as many distinct equations as variables to solve for the variables. You can't solve a system of equations when there are more variables in equations other than answering either there are infinitely many solutions or there is no solution. Why? Well, let's try x plus y equals 12. 6 plus 6 is 12, so x could be 12, x could be 6, sorry about that. Y could be 6, so x could also be 8, and y is 4, because 8 plus 4 is 12. 7 plus 5 is 12, negative 24 plus 12 is also 12. So we see there are literally an infinite number of values that could be x and y. So we need to be able to use another equation to pin down the value of each number. And you have to have the same number of distinct equations as you do variables. So if you have 3 variables, you need 3 different equations. That's what I mean by distinct. It's just different. If you have 4 variables, you have to have 4 equations. So what do I mean by distinct equations? Well, I just told you it means different. So for a system of equations to be soluble, that is solvable, not dissolvable in water or alcohol or some other solvent, you can't have one of the equations just be another one multiplied by a constant. X plus y is equal to 12 is the same as 2x plus 2y equals 24, because you just multiplied everything by 2. So if you have just that, then you're going to have this graph here where it's the same line. And I have seen in the Barron's SAT book, they talk about 2 distinct parallel lines. And I'm thinking, well, really, I wouldn't say they're parallel if they're the same line, but someone might. And so they're just driving it home that they are 2 distinct lines that are parallel in that particular problem, because they don't want someone coming up and saying, 2 lines can be parallel even if they're really the same line. You know, so like, no, we're not even going to go there. All right. 3 different ways to solve a system of equations. There's graphing, with the graphs that we saw there. You can graph each equation and find the points of intersection. It might work okay if you have a graphing calculator that will do 2 graphs at once. I'm not sure if they do that. I don't use graphing calculators very often. Otherwise, you're drawing a graph, and then it depends on the resolution of your pencil. On the SAT or ACT, the only paper you have to use is the test booklet itself, so you're not really going to be able to draw a very detailed, accurate graph. It's not the best way. It is often the first way it's taught. They want you to learn about it before they show you how to solve it algebraically. It's a really poor use of your time on the SAT or the ACT. I wouldn't do this unless you're just desperate, or you just quickly need to generally see what a graph looks like. Substitution is where you solve for one variable using one equation, so you get x in terms of y, and then you substitute the result in the second equation, so you have all one variable. So, x is equal to, say, 3y, then you plug it in. Oh, okay, well, this is 2x plus 4y in there. Oh, okay, so 2 times x is the same as 2 times 3y, so it's 6y plus 4y. Okay. So elimination is lining up the equation and subtracting or adding to eliminate one variable, then plugging that value into one equation to solve for the other. SAT system problems are often very easy to solve this way, especially if there are more than 2 equations. Just line them up. I guarantee you that the values will drop out. Okay, not 100% guarantee, but 99%, let's say. All right, so here's a quick substitution example. We have two equations, 3x plus 2y equals 12 and 4x plus 3y equals 17. You can tell by looking at these equations there's no constant you can multiply these by or anything else you can really do to get this to be the same equation as this one. So we have two distinct equations. Good. 3x plus 2y equals 12, so we can divide by 2 to get 3 halves x plus y equals 6. Let's subtract 3 halves x from each side, so we get y equals 6 minus 3 halves x. Now substitute this in for y in the other equation. 4x plus 3 times 6 minus 3 halves x, remember we're substituting that in for y, equals 17, so we distribute. 3 times 6 is 18, 3 times negative 3 halves is negative 9 halves. So this is all equal to 17. 4x is equal to 8 halves x, because we're just going to multiply by 2 over 2. So we end up with 8 halves x minus 9 halves x plus 18 equals 17. So negative 1 half x is equal to negative 1. Multiply everything through by negative 2, and then you'll end up with x equals 2. You can also, if that's too quick for you, just multiply by 2, then you get negative x equals negative 2, then multiply by negative 1, so you get x equals 2. Substituting 2 in for x into 3x plus 2y equals 12, you get 3 times 2 equals 6, plus 2y equals 12, so 6 plus 2y equals 12, so 2y equals 6, and y equals 3. You can also check it by plugging it into the other equation, so if we have x equals 2, 4 times 2 is 8, plus 3y equals 17, 17 minus 8 is 9, 3y equals 9, so y still equals 3. Yay, we know we did it right. Okay. Substitution example with multiple variables. You might be given something on the SAT or the ACT like what I did in my Properties of 1 video, which you can find here. And so let's say we have something like if A equals 2B plus 1, B equals 3C plus 2, and C equals 4D plus 3, what is A in terms of D? Well, first you want to substitute 1 in for D. That's why it's in the Properties of 1 video. If they don't give you values for the variables, you might as well take the smallest one and just make it 1, because 1's easy to work with. So C is equal to 4 times 1 plus 3, so that's just 4 plus 3 is 7. So B then is going to be equal to 3 times 7 plus 2, which is 21 plus 2. That's 23. Pretty easy, right? So A is equal to 2 times 23 plus 1. That's just 47. And then, so A is equal to 47 times 1. Since we set D equal to 1, that means A is equal to 47D. So you would just look for that answer choice, or probably you would just grid in 47 if it's a grid in answer on the SAT. All right, so here's an elimination example. Let's take 5x plus 3y equals 120, and another equation, 2x plus 3y equals 57. So first we want to make it so the coefficient of one variable is the additive inverse of the same variable in the other equation. So if the coefficient of x is 3 in one equation, make it negative 3 in the other. So here, y is the easiest to manipulate. So we can just multiply everything in this equation, 2x plus 3y equals 57, by negative 1, so we get negative 2x plus negative 3y. Yes, that's the same as negative 2x minus 3y, equals 57. So then we line the equations up and add from top to bottom. We have 5x plus 3y equals 120, and then we have negative 2x plus minus 3y. Again, it's the same as just writing negative 2x minus 3y equals negative 57. And so then you end up with 5x minus 2x is 3y minus 3y is just 0, so I didn't put it here. So we just end up with 3x equals 63. That means x is equal to 21, so you just divide both by 3. It's almost as though it's a contrived problem that I made up just for this demonstration, which I did, but hey, that's what they do with SAT and ACT problems. So you're going to substitute the value of the variable for which you've just solved. That is, you put 21 in for x into one equation and solve for the other. So here we're going to go 5x plus 3y equals 120. That means 5 times 21, which is the value of x, plus 3y equals 120. 5 times 21 is 105. plus 3y equals 120. That means 3y is 15. That means y is equal to 5. You could also do it in the other equation if you put in 21 for x and 2x. Okay, 2 times 21 is 42, plus 3y equals 57. 57 minus 42 is 15. 3y equals 15. Again, y equals 5. And it's a good idea to check these things in both equations just to make sure that you didn't make any mistakes. All right, did you find this video useful? Please, please, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours, that's 240,000 minutes, of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. Right now, I don't have anywhere near 1,000 subscribers. For the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, etc., tweet it, whatever. I'm always happy to read and respond to constructive criticism or suggestions for new videos. Let me know what you'd like to see. If I made a mistake, let me know. I make mistakes all the time. You do too. I reserve the right to delete comments from and block those who specialize in destructive criticism. It's a fancy way of saying trolls or things that are off topic, you know, spammers, disturb people. I've had people leave comments about whatever, and I'm just, you know, that's not what my comment section is for, pal. So I had to block them, delete their comments. So don't bother with that, please. And thanks for watching. That's awesome. Have a good day.